Right now, Jupiter's moon Io is still erupting. Hundreds of volcanoes tearing open its surface every single second, and NASA has no way to stop it. No way to fully explain it either. This isn't some slow geological process happening over millennia. It is happening right now as you watch this. And what scientists just found underneath Io's surface is something they did not expect. Something that, according to the models, shouldn't exist at all. But here's what nobody is telling you about what's really down there. Io is small, barely bigger than our own moon. It orbits Jupiter at a distance most objects wouldn't survive, squeezed by Jupiter's monstrous gravity on one side and pulled the opposite direction by two sister moons, Europa and Ganymede, on the other. That tug-of-war flexes Io's insides like a stress ball over and over and over again. The friction generates heat, immense heat. Enough to make Io the single most volcanically active body anywhere in our solar system. More than 400 active volcanoes, plumes rocketing up hundreds of kilometers into space. Scientists first caught one of those plumes by accident in 1979 in a single Voyager photograph. Nobody expected it. Nobody was ready for what Io actually was. For decades, the story held together, tidal heating, predictable, contained. Scientists built models predicting exactly where Io's hottest spots should sit, clustered near the poles, where the flexing should be most violent. Then Juno flew past in 2023 and 2024, close enough to map Io's heat signature in detail for the first time. And the map didn't match. Loki Patera, Io's largest volcanic depression, sat somewhere the models never predicted. Peel, T. Vashter. Pilin Patera, the one that resurfaced an entire region overnight while Galileo watched, back in 1997. None of them lined up cleanly with where pure tidal flexing says heat should concentrate. The pattern was wrong, not slightly wrong, fundamentally wrong, so researchers went back to the equations, adjusted the interior models, tried thicker crust, thinner crust, different viscosity for the rock underneath. Nothing reconciled the data. Some scientists proposed a global ocean of molten magma sitting just beneath Io's crust, based on magnetic readings from the old Galileo spacecraft, a hidden layer that could explain the mismatch. But then Juno's gravity measurements came back, and they contradicted that too. No clean global magma ocean, just an interior nobody can currently agree on. The people who study this moon for a living, Caltech, NASA's own Jet Propulsion Laboratory, are looking at the same numbers and reaching different conclusions. That almost never happens with a moon this well studied. Here's the part they're not saying loud enough. If Io's volcanoes aren't simply venting heat from tidal flexing in the pattern the math demands, then something else is happening beneath that sulfur-yellow crust. Maybe pockets of partial melt, scattered unevenly, shifting position over time in ways nobody can predict. Maybe the interior is layered in a way that funnels heat sideways before it ever reaches the surface, throwing every surface reading off. Loki Patera itself brightens and dims on a rough 540-day cycle, like it's breathing, and nobody has ever fully explained why. T. Vashter's plumes have been caught reaching 400 kilometers high, taller than the distance from Los Angeles to Las Vegas, launched straight up off a moon smaller than our own. And still underneath all of it is a structure we cannot map, driven by a heat source we cannot fully account for. This is a moon 2 spacecraft have orbited, 2 spacecraft have photographed up close, and we still don't know what's actually happening inside it. That should worry you more than it sounds like it should. Io is the closest, best observed example we have of tidal heating in the entire solar system. It's the textbook case. If the textbook is wrong here, every model built on it is suspect too. Every prediction about frozen moons like Europa, like Enceladus, worlds we're betting might hide life in oceans warmed the same way Io is supposedly warmed. If we can't correctly model the moon we've flown past a dozen times, what does that say about the ones we've barely glimpsed? Every mission planned to search for life beneath ice depends on assumptions Io is currently breaking. So Io keeps erupting, right now, while the people best equipped to explain it are still arguing about what's underneath. What is actually powering this moon from the inside, and why can 2 spacecrafts worth of data still disagree with each other? Nobody at NASA will give you a straight answer yet. Tell us what you think is really down there in the comments.